Hello, good morning, good afternoon, welcome. I'm very pleased to be joined by Sebastian Kopp. Sebastian is the head of electrolyzer research at the Fraunhofer Institute there in Germany, and he's going to be speaking and chairing a session at the World Electrolysis Congress. So, welcome, Sebastian. Thank you for joining me.
Thank you, Nadim.
So, obviously, World Electrolysis Congress, looking obviously at the area of your research, electrolysis. We've seen obviously lots of talk around, the two more mature technologies, AEL and PEM, and then the new technology. So maybe if you want to just unpick for people with some of your broad thoughts around the technologies and their potential sort of cost curves that they could follow, and what some of the advantages are and disadvantages of some of the platforms.
So yeah, as you introduced, basically, we have these large scale technologies that are already more established, I would say, AEL and PEM. Usually what we see in AEL is this kind of industry plant components and yeah, building in PEM, we have a more modular approach. Usually we have like a scaling of numbers in yeah, more dimension in the PEM electrolyzer world. Obviously, cost curves are limited by some factors in PEM, especially that's topics that you could not neglect. Is the raw material criticality of the materials in PEM. We're talking about iridium and titanium in the
Mhm.
electrolyzers that are defined by basically the chemistry and physics in the device itself. So yeah, we will see different cost decrease curves. Obviously, also in PEM electrolyzers, you need to say research is still quite heavy going on with reduction of these critical raw materials in there. So we will definitely also see a lot of cost decrease with PEM electrolyzers in the future.
Mhm. And potentially, reduced OpEx costs, because I guess with the AELs, you consider that to have some inherent costs around the running of those large scale operations. And would it be fair to say some of those units may be better in countries where you have a lower cost of labor?
Obviously, yeah, it's really depending where you run your electrolyzer. You mentioned it already. What we usually see is that classical alkaline, the larger your facility will be, the better classical alkaline electrolyzers will be in terms of cost. Just because you obviously need to have some maintenance on there on alkaline electrolyzers. They are per device a little bit higher than for PEM electrolyzers, so to say, which means the larger your devices get, the better your location is, the lower basically the OpEx gets, especially in terms of labor costs or something like this. Yeah, if you're like in a more low income country with like large devices, then basically your labor costs and OpEx will be very, very low.
Mhm.
If you have like yeah, medium or small sized PEM electrolyzers in higher income countries, for example, then also your OpEx will really depend on the sizing of the plant, also on the technical background of the system, how proven is it, and so on and so on.
Yeah. And in terms of AEM, we've seen obviously Enapter and people looking at sort of trying to, I guess, is it scaling lots of smaller units is their sort of path to cost reduction?
It's complicated. We see it actually in the market. We see different approaches at the moment. Like for classical AEL, obviously we're really talking about very large sized single devices, really like several megawatts single stack units. In PEM electrolyzer, we see also the same draw of the larger industry that they really go towards like larger single stack systems. So really talking about multi-megawatt stacks there. That's basically where like the big players in the industry, in the classical electrolyzer industry, heading towards. You mentioned Inapta. They have basically the vice versa approach. They really want to reach economies of numbers,
Mm.
less than economies of scale. It's actually complicated. We will see in the retrospective, basically after some years, which approach will be the most successful.
Yeah.
Um, a very, very small system and scaling up obviously has very big drawbacks because you will really need to have like lots of piping, etc., etc., behind it. Two large systems potentially could also be not the best way to go. But it's a complicated question. I can not give you a definitive answer on there. But yeah, we see industry like the established industries are really pushing more and more towards bigger systems.
Yeah, yeah. I mean, it's clearly going to be a case of, I guess, learn by doing, and what is essentially a technology race. I mean, in terms of other areas of innovation, are there any other sort of different pathways or other sort of future technologies that you think are coming into the space? And how innovative is it? You know, where are we? I mean, given all of the interest, and it's been comparatively short term, you know, it's only really been sort of 3 or 4 years where we've really seen a ramp up of interest, and therefore R&D dollars into this space. And typically it takes 10 years to, you know, to break a technology. So yeah, are we just at the beginning of a Cambrian, you know, explosion of innovation in electrolysis?
Um, yeah, it's complicated, I would say. In first, it's actually great to be in this time and see what happens, especially in this kind of applied research where we really have like this focus on also being able to look on different technologies. Obviously, within the next 5 to 10 years, what we will now see with the market growth will be AEM, AEL and PEM electrolyzers. So really the
Mm,
two classical technologies. We have AEM and then SOEL basically in the background. So really these two technologies are also still quite new, but more established. But it's interesting to see that there is more and more other technologies, be it like capillary fat electrolyzers, being like highly efficient PEM electrolyzer systems with gas feed, basically, be it combinations of batteries and electrolyzers and so on and so on. So there's many very interesting startups coming up and very interesting ideas coming up. I can actually not really say you which ones will be surviving in the long term, but at the moment we really see that in this wake of this hydrogen wave, there's many companies and research groups coming up with new ideas, which basically means that the classical established technologies, they will not be the end of the line, but we will need to see what actually the market will be like in the future. Will we
mm.
really see more this kind of big player dominated oil industry like market or oil and gas industry like market, or will you really have like some kind of more democratic market potentially with lots of small players with niche applications?
Yeah, yeah, indeed. It's going to be a fascinating space to track over the coming years, and we look forward to your contribution at World Electrolysis Congress, and indeed look forward to helping to accelerate this space with our networking events. So many thanks, Sebastian, for taking the time out to chat with us today to give us your insight over the whole landscape. And we look forward to seeing you in Düsseldorf come I think it's the 5th and 6th of March. So many thanks, Sebastian.
Thank you very much too, Nadim.
Yeah, cheers. Take care. Bye bye.